we'll discuss some introductory concepts of operating system, like what is operating system, what operating system do, and what are major functions of operating system. We'll also discuss some computer architectures. So let us start. We'll start with what is an operating system. Operating system is a program that acts as an intermediary between a user of a computer and the computer hardware. Operating system is actually like an interface. It's an interface that is used in between computer hardware and computer users. Because computer users cannot execute their jobs. Computer users cannot execute their jobs, their computing problems, cannot solve their computing problems directly on the computer hardware. Computer users cannot accelerate computer hardware unless they know some computing languages, some computer native language like binary language or machine language. And that's where operating system is needed. Operating system used as an interface between computer hardware and computer users. What are the goals of operating system? Operating system have many goals, and main goal of operating system is to execute user program, is to execute user jobs, and not only execute but execute in a convenient manner, so users can easily execute their jobs, users can execute their computing programs, and users can solve their computing problems. Another goal is making the computer system convenient to use for the user. And another goal of operating system is use the computer hardware in an efficient and effective manner, because resource utilization is also important aspect of computer system. Now let's discuss something about computer system structure before we go in detail about operating system functions. Computer system can be divided into four components: hardware, operating system, application programs, and users. Hardware provide basic computing resources, and basic computing resources, most important resources are like CPU is the most important resource, memory is the important resource, and there are other resources like IO devices. And operating system, as we have discussed, that it's a software, it's a set of program that is used as a middleware program, that is used as an intermediary program, used as an interface between computer users and computer hardware. And then next component, application programs. Application programs are those programs that users use to solve their computing problems, and word processors, compilers, web browsers, database systems, these are all sort of application programs. Last component is the users. Users are the people who use the computers, and sometimes machines or other computers are also type of users. Look at this diagram. There we can see four components of computer system and then the role of operating system. Here you can see users, topmost, user 1, user 2, user 3, and these users use a system and application programs. System and application programs are used by the user to solve their computing problems. And here is the operating system and its intermediary role. These system and application programs cannot be executed on the computer hardware, and users cannot execute their jobs on the computer hardware unless there is an operating system. So operating system used as an intermediary between these system and application programs. So users use system and application programs, and then system and application programs use operating system, and then these jobs are executed on the computer hardware. What operating system do? What operating system do? It actually depends. It depends on the point of view. There are different point of view as there are different environments. I will start with the user point of view, and later we'll discuss about system point of view. According to user point of view, there are also different environments. as a user is sitting in front of a personal computer or desktop computer, and it's a single user environment, a single user is using a single computer, so there is no concept of resource utilization. So operating system designed for this environment will be focused on ease of use and good performance. So operating system that is designed for a single user, for a single computer, does not focus on resource utilization. And its major focus will be ease of use and good performance for a single user. There are also some shared computers such as mainframe or mini computers, maybe a user sitting on a terminal and terminal connected to mainframe computers or mini computers. And in this environment, operating system has to make happy all users. And how operating system make happy to all users? By sharing the resources. So resource sharing is most important in this environment when mainframe computers are being used or mini computers are being used. So performance and ease of use and convenience, it's less important, and resource sharing and resource utilization is most important in this environment. And there are other environments like users are sitting at workstations and workstations connected to networks and have some dedicated resources, some shared resources as well, like print servers, like file servers, and like other servers. And then environment of handheld computers. Handheld computers are resource poor, optimized for usability and battery life. And then other sort of computing environments, that computers which have little or no user interface, such as embedded computers, that computers that are used in devices and automobiles. So what operating system do is depend upon user environments and role of operating system in that environment. On last slide, we have discussed about user point of view. Now we will discuss something about system point of view. System like an operating system. Operating system is a resource allocator. Resource allocator which manage the resources, which use the resources and which distribute the resources among different jobs and different programs. And operating system decides between conflicting requests for efficient and fair resource use, because all program who wants to use resources, who wants to execute, needs resources, they submit their requests to the operating system, and operating system receives so many requests, and even sometimes operating system receive conflicting requests. In this case, in this scenario, operating system decides that how it can allocate the resource fairly, so all programs can get the resource on their turn. And another point of view is operating system as a control program. Operating system is a control program that controls the execution of program to prevent errors and improper use of computer hardware and computer system. Operating system definition. There is no universally accepted definition that what should be the part of operating system or what is the part of operating system. Everything a vendor ships when you order an operating system is a good approximation, but varies widely. There are different vendors of operating system, and all vendors use different type of system programs and other application programs or utility programs as a part of operating system. But there is the one program running at all times on the computer is the kernel, and that is the main operating system. Kernel is the core of the operating system, center of the operating system. Everything except kernel is either a utility programs or either a application program. Computer system architecture. Before we discuss the other details of operating system, it is required that we should learn something about computer system architecture. Computer system can be organized in many ways. We'll discuss about the number of processors used in a system. First of all, we'll discuss single processor systems. Single processor systems are those systems that use just one processor, one single general purpose processor, and sometimes any sort of special purpose processor. General purpose processor mean a processor that can perform all tasks, that can perform all processes, that can perform all jobs on the computer. And special purpose processors are those processors that process limited instruction set and that do not execute user jobs. Another type is multiprocessor systems. Multiprocessor systems are those systems that use at least two processors or more than two processors, and sometimes known as parallel systems or tightly coupled systems. And advantage includes increased throughput, economy of scale, and increased reliability. Increased throughput means that number of jobs completed in a given time is increased, as we are using two or more than two processors. So we are expecting more work to be done, more jobs to be completed, more tasks to be performed in a given time. That is called increased throughput. Economy of scale means that the cost of multiprocessor system is less than the cost of equivalent single processor multiple systems, because multiprocessor systems share common resources, and other like single processor multiple systems do not share resources, they require separate resources. And increased reliability. Increased reliability means when we use multiple processors in a system and failure of one processor does not halt the entire system. Let's say we are using a multiprocessor system with five processors, one processor fails, and failing of one processor will not bring the entire system down. It is called increased reliability. Reliability increased with using multiple processors. There are two types of multiprocessor systems. One is asymmetric multiprocessing and other is symmetric multiprocessing. First, we will discuss symmetric multiprocessing architecture. Difference is between about sharing. There are many differences between two types, but major difference is about sharing of computer memory. You can see in this diagram there are multiple processors, CPU 0, CPU 1 and CPU 2. These are multiple processors. Every processor has its own registry and cache memory, but they are sharing the single memory. This architecture is called symmetric multiprocessing architecture. And this diagram represent a symmetric multiprocessing architecture. You can see there are multiple processors, processor 1, processor 2 and other processors, and every processor has its own private memory. Look at this, processor 1 has its own memory, processor 2 has its own memory, and other processors also have its own memory. In asymmetric multiprocessing architecture, there is a master processor. Master processor is the main processor that actually controls and coordinates between other processors. So this is the major difference between symmetric and asymmetric multiprocessing.